Welcome to Calculus. Whatever confidence you have will be tested. But don't worry, Stevenson has tools to help you. On this episode, Stevenson will demonstrate
Now let's try practicing those properties that we just reviewed. I have a few problems set up for you that I have taken from the textbook. So here's the scenario, or here's the question stem. Suppose the integral of f of x dx from negative 1 to 1 is 5, the integral of f of x dx from 1 to 4 is negative 2, and the integral of h of x dx from negative 1 to 1 is 7. Find each of the following if possible. So let's look at the first one. So this says the integral of f of x dx from 4 to 1. Okay, now remember, what do definite integrals represent? They represent area under a curve. So when you look at these values under here, they're telling you, hey, the area under f of x dx from negative 1 to 1 is 5. The area under the same function, f of x, from 1 to 4 is negative 2, and the area under the h of x function from negative 1 to 1 is 7. So when you look at this one right here, this is saying, what's the area under f of x from 4 to 1? Well, we don't have that. So what we have to do is use those properties in some creative way to manipulate it to try to align with something we do know. We do know the area under f of x from 1 to 4 is negative 2, but these bounds are reversed. So we can use the property to reverse the bounds. And in doing so, we put a negative in front. Now we have the integral we need. So this says negative 1 times the integral of f of x dx from 1 to 4. Well, the integral of f of x dx from 1 to 4 is negative 2. Let's look at the next one. So this is the integral of f of x dx from negative 1 to 4. Okay, so we have two integrals that deal with f of x dx. We have negative 1 to 1, but then we have 1 to 4. But we don't have negative 1 to 4. Well, look, if we go from negative 1 to 1 and then 1 to 4, then we can link them. See that? Where this first integral ends at 1, it begins on this one at 1. So we could use that integral property that allows us to link those two together. So this integral is equal to so the integral from negative 1 to 1 is 5. The integral from 1 to 4 is negative 2. And there's our answer. Now in this one, we have the integral from negative 1 to 1 of a sum. So we want 2 times the f of x function plus 3 times the h of x function. And notice the brackets, that's the whole integrand, and then dx. So this is going to be that sum rule. So what we first want to do is split this up as a sum of the two integrals, or the two integrands with their own integral. Next, I want to use that constant multiple rule. So in the first one I have a 2, I'm going to move it out front of the integral, and in the second one I have a 3 to move out. Now I'm ready to actually use my values. So I have negative 1 to 1 of f of x dx, and if I look at my list of values at the top of my paper, I can see that is going to be positive 5. And then I have negative 1 to 1 of h of x dx, which tells me it is 7 up top. Now I just do simple operations. Let's look at this next example. So this is the integral of f of x dx from 0 to 1. So when I look at my list of options up here, or what was given to me, I do have some integrals with f of x, but I only have 0 to 1. In what's given to me, I don't have anything with a 0 in it. I have negative 1 to 1, I have 1 to 4. Now you might be thinking, well, why can't we just take half of this one? If that's from negative 1 to 1, then 0 to 1 would be half of that interval. Here's the problem. We cannot assume how the area is allocated on this interval. In other words, we can't assume from 0 to 1 half the area is in one location, and from negative 1 to 0, the other half of the area is there. We cannot assume that. All we know is the total area is 5. So in this case, there's not enough information. Alright, let's look at the next one. The integral of h of x dx from negative 2 to 2. Well, this is what I know about h of x. I know from negative 1 to 1, it's 7. Notice the bounds changed from negative 2 to 2. Well, I don't know anything about anything with 2 or negative 2. You may be thinking, well, why can't we just double the bounds, thus doubling the area? Again, we cannot assume how the area is allocated over this interval to get 7. Right? Is there more on the positive side or more on the negative side? Or is it all positive? If so, how? We don't know. We don't know what lies beyond this interval negative 1 to 1 in order to safely assume that it has to be 14. So there is not enough information. So in this one we can see we have a sum of f and h again. So let's go ahead and split them off as two separate integrals. Now in this first integral, negative 1 to 4 of f of x dx, we actually figured that out in a previous problem, right? Remember we did that property, that additivity property that linked two integrals together. But this is an h of x integral now. And the only thing we know about h of x is from negative 1 to 1. So although we can figure out the first one, we cannot figure out the second one. We don't have enough information for it. So that means we don't have enough information for the problem as a whole.